Right, grade 12, I just want to revise a few basic rules of exponents and surds before we get into some more advanced types. And I'm going to write them up here. The one rule says if you've got x to the n and you divide by a, what we can do is we can rewrite that as 1 over a x to the n. Remember, you want to apply rule 1, rule 2, and rule 3 of differentiation, and we have to be able to express expressions in that form. So, for example, if you had, say, x to the 4 over 3, we could write that as 1 over 3 x to the 4. And now we can apply rule 1. You see, it's a x to the n. Okay, that's the one rule. The second rule of exponents would be this. If you had, for example, a divided by x to the n, if it went the other way around, then all you do is you write a and you then apply the rules of exponents and bring that up. Okay, x to the n goes up and becomes x to the negative n. So, for example, if you had 3 over x to the 4, that would be 3x to the negative 4, ax to the n. Okay, another little rule of exponents that you could use as well is if you had, for example, a divided by bx to the n, this can be a over b x to the minus n. So you write the a over b and bring that up there. Okay, and then number d, this rule is quite nice too. If you've got a over, if it's the whole of bx to the n, then all you do is you write the a and bring the whole bracket up, and it becomes negative n. And then just watch out for the rules of surds. If you've got a divided by the nth root of x to the m, well, we can say that that's a divided by x to the m over n. If you remember, you get the rule of surds, and then that comes up and becomes a multiplied by x to the negative m over n. Okay, and we're going to apply all of these rules when we do some examples. So now I'm going to come back to those rules, but let's have a look at some examples, and we'll call this example 1. And what I want to do is I want to show you, if you want to determine the derivative, if you want to determine g prime x, if gx is x cubed over 3, so you've got to determine g prime x, that's what you want. Okay, well, it's not quite of the form of rule 1. What we can then do is apply the exponent rule, but notice I keep gx, I'm not differentiating. By the way, the word differentiate is getting the gradient or derivative. They say the word differentiate, find the derivative, get the gradient. So I can convert this to 1 over 3x cubed, ax to the n, and we can now use rule 1 effectively. We can say g prime x is 1 over 3, keep that there, bring down the 3, subtract 1 from the original, and there you go. So g prime x is equal to 1/3 times 3 is 1, and we're left with x squared. There's your derivative, your slope, your rate of change, your gradient, using the rules of differentiation. But you have to first rework this in a form that will adhere to rule 1, 2, or 3. Okay, if you look at another one quickly, let's have a look. Say you're given y is equal to 3 over 2x to the 4, and you're required to find the gradient dy dx. What is that? Okay, well, firstly, it's not really nicely organized, so I'm going to write y equals, and if I apply the rules of exponents, go up to this one. Let's have a look here. If we have a look at this rule over here, where is it here? This one, number C. We're going to apply that rule. And what happens here, it looks like this. It goes 3 over 2, and we bring that x to the 4 to the top. Look here, ax to the n. We can use rule 1. Now we can say dy over dx is equal to 3 over 2 multiplied by, bring down the negative 4, and subtract 1 from the original exponent. And you would then have dy over dx is equal to, well, 3 4s are 12 over 2 is 6, so it's negative 6 x to the negative 5. Okay, and that would then come to, if if you think about it, it will be negative 6 divided by x5. We always like to keep our exponents positive. There's the derivative, the gradient, the rate of change. Okay, have a look at this number c here, a little bit more interesting. What if you have dx? Look at that notation of the square root of x. Well, no problem. Dx, keep that there, keep the equals there, keep the dx, and remember this is the square root of x to the 1, which is, of course, dx of x to the half. Now we can use rule 1 to deal with this. We drop the dx and we say 1 multiplied by half x to the half minus 1. There we go. And we have equals 1 times a half is a half, x to the negative a half, and all you now need to do is bring down that x to the negative half, bring it to the 2 in the denominator, and there we go, 2x to the positive a half, and if you like you can go 1 over 2 root x if you want to reverse that, and there's your derivative there. Okay, so these are the important things with the rules of differentiation. Make sure that you get the expressions to look like ax to the n or ax. If it's just a number, it's not a problem. So use the rules of exponents to do that. Okay, should we look at some really advanced differentiation? And I always say to students, always get rid of brackets. If you see brackets, if you see divide lines over variables, divide lines over variables, that's very important to get rid of those things. And then also if you've got root signs, we always get rid of these things before we can apply rule 1, rule 2, and rule 3. Now have a look at this. So it's brackets, divide lines, and root signs we've got to be careful of. So let's look at some typically advanced kinds of questions that they can ask you. Say they said differentiate, get the derivative, determine the rate of change, slope, gradient, determine the derivative of 4 divided by 3 multiplied by the 4th root of x cubed. How are you going to do that? Well, firstly, we've got a divide line over a variable, we've got a root sign. And notice I'm going to write y equals first. Then I go 4 divided by 3 multiplied by x to the 3 over 4. You get rid of the root. Then if you apply the rules of exponents, look at that, it's still y equals, you can go 4 over 3 x to the negative 3/4. There we go. Now you're in a position, you've got it in the form of rule 1, which is that. So you now say dy over dx is 4 over 3 multiplied by, bring down the exponent, and subtract 1 from the original exponent there. Okay, so what is dy dx then equal to? Well, this is wonderful because that's negative. The 4's and the 3's cancel. So it's 1 x to the negative, or negative 3/4 minus 1 is negative 7 over 4. And your dy dx then comes to negative 1 divided by x to the 7 over 4. And there you've got it there. You've got the derivative of that function. Okay, you got rid of the roots and the divide line. Okay, how about this one, number B? If they said to you, work out the dx, the derivative, and you've got a little squared expression there. You've got brackets and a root. Now what I'm going to do is I'm going to apply the principles of multiplication. Well, what does it say? If you're stuck, you could actually say, well, okay, fine, let me rewrite that twice. If I'm stuck, you could rewrite that bracket twice if you're not happy with the shortcuts from the past. So have a look at this. You could then say, well, what is root x times root x is x. Root x times 3 is 3 root x. And 3 times root x is 3 root x. And 3 times 3 is 9. Okay, notice how I keep the dx. I haven't differentiated yet. So that's x. 3 sheep plus 3 sheep is 6 sheep plus the 9. Okay, now we've got rid of the brackets. Now all we have to do, that's a 1x, we have to get rid of the root. That's x to the half, as we did before. Okay, no problem. Okay, so now we can differentiate, and it comes to, we drop the dx symbol. This here is rule 2, so it's 1. Then we've got plus 6, bring down the half, and subtract 1 from the half. And this is rule 3, which is naught. So what's that? That's 1 plus 3x to the negative a half. And that, of course, comes to 1 plus 3 divided by x to the half. Or, if you like, 1 plus 3 over root x. Okay. These are typically what they ask in exams. Okay. Have a look at this one, number C. What if you had dx is equal to x squared minus x minus 6, and all of this is divided by 2x squared? Well, you can't just apply the rules over this divide line over variables. So what we've got to do is we've got to separate it. Now, if you remember in grade 8, what we did is if you take x squared minus x minus 6 divided by that one term at the bottom, you can divide each of them by 2x squared. It's the reverse of getting the LCD, if you remember that. If you look at this, if you divide everybody by 2x squared, if I said to you, simplify this, go from here to here, well, the LCD is 2x squared, you would have drawn a one long line and put those guys on top of the divide. Okay, now let's simplify this. Notice, keep my dx, and that gives you x squared over x squared cancels, so it's a half, minus, there's a 1 there, so it's actually 1 over 2x to the 1. And this gives you 6 over 2 is 3 over x squared. Alright, there we go. Remember, there's an x and an x squared. That equals, okay, now what's this going to give us? Dx, we can keep a half. This is going to give you a half x to the negative 1 minus 3x to the negative 2. If you bring up the x squared and you bring up the x to the 1, you're now in the form that you can apply the rules. So what does this equal? Now we can drop the dx, the derivative of a half is 0. Then we've got negative a half multiplied by negative 1x to the minus 1 minus 2 is negative 2. Negative 3 multiplied by negative 2x to the negative 3 if we subtract 1. This gives you a minus and a minus a plus. Half times 1 is a half x to the negative 2 plus 6x to the negative 3. And then what does this give us? 1 over 2x squared, look at that, plus 6 over x cubed. There, we've got it. Okay, guys, so be aware of this thing. This is quite a challenging question, but this is what they can ask you in an exam.